Hello and welcome to this SimScale webinar on Revit to Simulation, Urban Microclimate Analysis with SimScale. My name is Dr. Nagman Khan. I'm delighted to welcome you all here to this event today. I'm joined by my colleague, Darren Lynch, who's a Senior Application Engineer from SimScale. And today we have a very interesting topic around the application of simulation in the built environment. More specifically, looking at going from different CAD tools, the workflow needed to make your CAD model simulation ready. Specifically, we're going to touch on Revit today, but in the question and answer session, we're happy to talk about other types of common CAD tools you might be using. So let me quickly introduce SimScale. Why are we here? Well, we're empowering architects and engineers to innovate faster. And we're doing that by making high fidelity engineering simulation accessible from everywhere and at any scale. SimScale is the first fully cloud native simulation software in the world, and it's accessed through a web browser, any web browser that you have, which means it's scalable and it's accessible and it's easy and intuitive to use. Let's take a look at today's application. Well, we all know architects and engineers know the struggle of using complex geometry and CAD models for simulation purposes. CAD cleanup is often cited as the greatest bottleneck in making design decisions. Now, we have some really great features in SimScale that lend themselves to accepting complicated and untidy CAD models. For example, from Revit. One of the solvers that we use is called Pacefish, based on the Lattice-Boltzmann method. And it means that you don't really need watertight geometry, to make your CAD model simulation ready. On top of that now, Revit has a new feature that allows designers to export in a simple 3D format that's easily imported into SimScale. So this webinar will feature a step-by-step process starting from within Revit and demonstrate importing, simulating, and analyzing the results in SimScale, looking at, in this example, pedestrian wind comfort and building aerodynamics. A quick agenda, we're going to show you quickly the SimScale platform and then look at importing Revit models into SimScale, running a pedestrian wind comfort simulation, looking at some results, how easy that workflow is, and then we'll have a Q&A session at the end and we'll show you how you can get started with using SimScale. Please do keep the questions coming from the question panel in GoToWebinar. Now I'm going to hand over to my colleague Darren Lynch for the live demonstration.
Hi and welcome to this demo on a Revit to SimScale workflow. So the real topic of today is understanding how we can take a Revit project or a Revit geometry, a BIM, and bring it into SimScale. And what we're going to do is firstly show you the SimScale workflow. So once you've actually brought this geometry in, how do we set up one of these simulations and what is the outputs you can get for that? And then we'll take a detailed look at what we can do in Revit to help this process, to enable this workflow, so to speak. So let's get started. So let's first look at the workflow. So this is the SimScale platform. It's got a large 3D viewer or visualization in the middle. And this is where you can view results, view the geometry that you've uploaded, and also interactively make any assignments you wish to the simulation setup. On the left-hand side, this is the simulation tree. So this is where we're actually inputting parameters into the simulation. It's also where we can upload our geometries. And on the right-hand side is the geometry tree, where we can see that we've got two layers. We're going to call them layers for the rest of this webinar. And also chat. So if you've got any questions as a professional user at SimScale, you can actually start a conversation with myself or one of my colleagues about anything to do with the simulation setup or simulation in general. And we can actually jump in, help you live with the project. And this is actually a much better system than a traditional ticketing system. So, Revit to SimScale, where do we start? Well, we would typically start by uploading geometry. I'm going to talk to you about how to prepare that geometry in Revit itself later, but I'm going to show you the upload process first. So the upload process starts by coming along to geometries in the simulation tree, and we press the little plus button to bring up a dialog box. Now we're going to follow the dialog to import geometry from our computer. Now we can go import, we can go straight to Revit to SimScale. Now what we've got is a zip file, and this is what we're going to be uploading. What is contained in that zip file is 2 layers. Now these layers represent the layers that are maintained in the geometry when we upload the file. And this makes it easier for us to set up a simulation later. And of course this is what we're going to be showing you how to produce in Revit later. But for now, know that we've got to export a zip file of the layers in STL file format, and I always recommend the STL file format because it allows us to more robustly deal with these geometries from Revit. So we click our zip file of STLs, we open it, we tell SimScale that it is an STL file, and we keep the default settings where we use the meter, we use all of these selections. Note, of course, if you were using millimeters and you exported as millimeters, you would change this to millimeter. And we press import, and that goes through our import process. It does some sort of cleaning to the geometry, it does some face splitting, and then it returns us our geometry as layers, like so. So here we can zoom in and we can actually see the simple building that is actually, you can notice, is the example file from Revit. And we can see our 2 layers, one representing topology in blue and one representing the building in white. So we're going to create a new simulation. We're going to create a new pedestrian wing comfort simulation, which is external building aerodynamics. And we're going to say, what is the region of interest? What part of this geometry are you actually interested in? And I'm going to say, I'm actually interested just in 100 meters around the building. I'm going to leave the settings as default. And we're going to save. Next up, what I'm going to do is I'm going to tell the solver where this building is. Where in the world is it? Well, I actually picked, for the example, a location I know quite well. So I'm going to go Greenstone in the UK. And this is quite a coastal area. So we'll import the windrows and we'll knock it down to 8 wind directions. And we want to actually tell it what is around this area. So to the north, what's to the north? Well, let's say it's urban area. There's other houses. To the northeast, we've actually got flat terrain. It's beach actually. To the east, it's actually coastal area. To the southeast, it's coastal area. To the south, it's flat terrain, beach. To the southwest, there's houses. To the west, it's open terrain. Sorry, open terrain. There we go. And to the northwest, that's actually houses as well. And we can save that. And finally, what we want to do is to tell the SimScale platform where a pedestrian is going to be standing. So obviously it's around the house, but it's probably more important that we look at the building that we've just designed and the outdoor spaces that we're going to have people standing on, because we can't really control the outdoor space. That's just as it is. We could introduce trees, of course, to make the garden and the surrounding areas more comfortable, but really what we're interested in is the outdoor spaces around the building. So I'm going to go around and select those. So they're going to be standing in the drive, they're going to be walking down the ramp towards the house. They're going to be standing in the courtyard area around the building, and also on this little balcony here as well. And not forgetting this outdoor area here. So this section, and also why not include the stairs? Okay, so this represents well everything that a pedestrian could be standing on in and around this house in terms of external building aerodynamics. And we save that. Now, in terms of simulation setup, we don't have to do anything else. We could actually come along and we could create a new simulation where it would estimate the resources, the compute time, and also how big the mesh is and how large the cell size is. And we can start that simulation. Now, what do we get out of these simulations? Well, first and foremost, we get a comfort map. So if I was to say, I'm standing on the balcony of my house, how comfortable would I be? Okay, and this is actually a measurement of comfort in respect to the activity that a person would be doing. And it's combining the results of the CFD for each individual direction and the wind results that we pulled in for this particular area. And we can see that there's this heat map, and it means that anything that's dark blue, like this area here on the balcony, you'd be okay outdoors dining. So I could be outdoors on this balcony eating a meal, watching the sunset. In contrast, if I was in this area, I won't be comfortable dining, but I might be comfortable sitting in some parts, but more likely it's standing and walking only. So quite a transient activity set there. And you can see that how that plot looks at, throughout the entire comfort map, but noting as we get further away from the house, we've got some uncomfortable regions that we could of course mitigate by putting some trees in at a later date. Additionally, you could also get wind speed results. So for individual wind directions, what do the wind speeds look like? And these are all available under directions. But I'm not going to spend too much time there. What I'm actually going to do is I'm now going to move over to Revit and show you how to set this geometry up, how to prepare it, and how we can then make the most of this super automated and fast workflow. So I think the best way for me to show you how to create these two views that we use to export our two STL files to the SimScale platform is to actually start this new project and do the workflow from scratch. So I'm going to show you how I got those two views. So the first thing I'm going to do is I'm going to come along to the 3D views section. Firstly, you'll note that this is the basic sample project supplied with Revit, just to give us something to work with. So come along to 3D views, and we're going to peer into the standard 3D view. And you'll see that everything in our model is represented here in 3D, which is great. But what I'm going to start with is I'm going to start by creating a layer or a view just for topology. And to do that, I'm going to start by renaming this. So I'm going to duplicate the view. I'm going to rename the first one original topology. So there we go. Original topology. The second one I'm going to rename buildings, and of course we'll get there. I'll show you how to create that. Buildings. There we go. And eventually we're going to have buildings, original topology, and final topology. That's what we're aiming towards. The first thing is the topology. Now, we mentioned earlier that we wanted to extend the default or the current original topology because at the moment it's not sufficient for CFD simulation. If we put a wind tunnel around this, the edges of the topology would influence the results. Really, we just need this to be extended past any boundary that is held by the wind tunnel. which means in an ideal world we'd want to grab this face and move it out. We want to grab this face and move it out, say a couple of 100 meters, maybe a kilometer. In practicality, however, it's not that easy in Revit. We can't just grab this face and move it, grab that face, because firstly you're going to deform your topology, but secondly that's just not an operation we can do. So I created a custom node in Dynamo to actually help us out here, but we need to do a bit of preparation work before we get there. So first we're going to come along to our original topology view, and we're going to make sure that only the topology is actually in the view. So we're going to go to Visibility and Graphics, and we're going to roll down to Topology. There we go. We're going to select Topology and invert that selection. And of course hide everything else that isn't topology. And apply it. There we go. I know it's green, so it's not very visible there, but we have got two building bases here that we need to maintain, but we'll worry about that later. The first thing we've got to do is extend this topology. So we're going to go to Dynamo. So the workflow is that we go to Dynamo, we select the topology that we want to extend, we define how far we want to extend it, and that will export us the geometry that we need. Okay, so I've loaded up Dynamo. So on the left here I've got Revit, on the right I've got Dynamo, and what you can see is we've got actually an additional add-on called SimScale. So this is where I have developed a custom node. I'm going to bring in that node. It's called Topology Extension. So the way we structured it is SimScale, Topology Extension. So let's bring that in. So you can see that the input is the target topology, this topology, and an extension distance, some number, and that is in millimeters. And what we're going to do is when this starts working, we're going to see exactly how we perform this task. Okay. So first thing, let's select an element, or a model element, I think it's called. Select model element. There we go. Let's select this geometry. There we go. And we assign that as the target topology. So far, so good. Next, what we want to do is define a number. Of course, this is in millimeters. So if we wanted to extend it 200 meters, it's got to be 200,000 millimeters. I actually found that wasn't enough, so let's go to 500,000 millimeters. And we assign that as the extension distance. Now, it does a bit of thinking, which is great. Now, what we'll see is we've got another topology here, but it doesn't look any different than the other topology. Why is that? Because we're actually restricting the visualization. We've actually got a section box by default. So we're just going to remove that section box, and then you'll see our extended topology. So we've taken the topology inside this area and we've extended it. Okay, so we've actually put a circle of points all the way around here and redrawn that topology. But you can see an obvious issue. So our building bases are not cut out of the new topology. So we're going to fix that. But first and foremost, the topology extension is done. So we can actually close Dynamo now. So thank you very much, Dynamo. You've done your job. So I'm just going to minimize that and expand Revit again. Here we go. So the first thing I'm going to do is duplicate this original topology. I'm going to duplicate that view, and I'm going to rename it Final Topology. voila. So under sectional of the original topology, we're going to actually move to this this view, and under original topology we're actually going to hide this object, this new topology, by right clicking and hiding in view the element. So now the original topology view has got the original topology with its cutouts, and the final topology view we want to do the same. So we can go to the original topology, right click, and we can hide that element. We also want to do the same this time to the bases. There we go. So how do we go about taking the building bases from this topology into the new topology? Well, it's actually easier than you might think. So we can actually click on that building base, copy, move to our final topology, clipboard, and paste, aligned to the same place. And you can actually see that's been cut out now, out of our new topology, which is quite clever. And we just repeat for the other one. So go back to our original topology. We can copy it to that dashboard, and we can move to the final topology and paste it in place. Like so. So now we actually have one of our final views. This is ready to be exported. So like before, we would go File, Export, CAD formats, and STL. I won't show you that again, but same process as before. So we've actually got one of our views ready. Now, the final step is to get this building layer ready. And thankfully, we've actually done all the hard work. So this is quite an easy step. So we can go onto our buildings view, where we can see the original and the new topology is now here. What we can do is simply modify this view. So let's firstly get rid of the section box. Lovely. And then what we're going to do is we're going to actually remove everything that isn't building. So that includes the topology. For this example, I'm also not going to include the trees, because as you can see, these are 2D trees. They actually need to be 3D for simulation. Just for today, we're going to leave those out. We're also going to take out a lot of other details that aren't necessary. I'll talk you through that process as we're going. So once again, we're going to go to Visibility and Graphics Overrides. And the most obvious one is probably going to be topology. So let's go straight to topology and untick that. There we go. Next up is trees. Now trees are actually under planting. So if we come to planting, I've gone past it. There we go, planting. We're going to hide planting as well. There we go. And what we can do is systematically work through the other sections and see if we actually need it or if we don't. Now, I would advise actually in this case, if you're going through ticking lots of things, do it in sections, apply it, and make sure that you haven't got rid of something that is actually what I would call aerodynamically significant. Okay, so we're doing an external building flow analysis. What is significant to this simulation? Now, obviously, walls are significant, roofs are significant, this building base is significant, windows are significant. What isn't significant? 2D models of people, pipes, taps, fittings, fixtures, furniture. These are not significant to an external building aerodynamics problem. And although SimScale is incredibly robust to geometry, there's no point making our lives hard for ourselves. So we might as well get rid of them when we export. So we can work our way through. A good basic model here that represents well the building that we want to simulate. All of the key features You can see there's a few things that we could have removed that didn't come up in some of the typical options, but that's okay. You know, we've whittled it down to something that's reasonable to be simulated. And this represents the building that we can export as a new layer. So we can export this view as a new layer in combination with the layer that we previously created for topology. We've actually got both of our layers. And I'll show you once again how to do that. Go File, we'll Export, CAD Formats, and STLs. So we can select the defaults. This time we choose meters again, and we save that. And when we go into export, we want to export as buildings.stl. And we can overwrite our previous one. And there we go. We have now created both of the layers. We can zip both of those up as we did before. So we can select both, turn it into a zip file as we did before, and upload that to SimScale like so. And that is the Revit to SimScale workflow for external building aerodynamics. And Nagman, I think you're muted.
Hello, everyone. Thank you for that. Darren, fantastic presentation. Let's take some questions, Darren. I believe you can see them in the question panel that they're coming in from the attendees. Darren, a couple of questions. Maybe talk a bit about the weather data. We've had several questions on that, on the scope users have to define weather data and what kind of weather data sources we use, please.
Yeah, absolutely. So when we're setting up the wind data within the SimScale platform, you've actually got two options. So you would start by typing in your location. In my case, it was Great Stone in the UK. Once you've typed in that, you've actually got two options. One, to import the data directly from our connected cloud connected service called MeteorBlue. That is quite automatic, so you don't have to do anything. It brings in the data for you, and you can just select how many wind directions you want to choose. The other option is actually to upload your own weather file. That has to be a stat file, so a .stat file, and they're quite common. They're available for most airports around any country, really. One typical source might be climate.onebuilding.org. That's very popular, and they've got a huge amount of stat files available for you to use, and that all represents annual statistical data.
Great, thank you, Darren. Several of you are asking about a recording for this webinar. So yes, if you registered for this event, which you're online, you'll receive a follow-up email in a couple of days. So it might be early next week now, with a link to this recording as well. And if you have any questions for us, or if you'd like to discuss your projects in particular, you might have a Revit model that you're thinking, how can you make that simulation ready, with SimScale, please do get in touch with us. There's an email on the slide there, sales@simscale.com. Please get in touch, and then Darren and colleagues will be happy to discuss your projects and your models with you as well. Darren, should we take a couple more questions?
Absolutely, yeah.
Yeah, so the model you showed, Darren, in the demonstration, how long might that take to simulate? And another question related to that model is, could you view the 3D mesh and what control do you have over the mesh?
Yeah, so in terms of speed, for that particular simulation, I think results were done in around 30 minutes. So that was quite a quick simulation, but it was also just a singular building. I think a typical solve time would be less than 2 hours. And that's because we're making the most of parallel processing. So we're solving each wind direction on an individual machine. We're also using super fast GPU instances for our solves as well. So all in all, a turnaround time for 8 wind directions, we wouldn't expect it to be more than 2 hours, which is really fast for a CFD calculation.
Exactly, for transient simulations.
Exactly, yeah.
Go on, Darren. Yeah.
Yeah, and so I was just going to address the 3D mesh question.
Yeah.
I assume that talks about the simulation mesh rather than the geometry mesh. Is that?
That's right. Yeah.
Yeah. So the simulation mesh, yes, you can view that. It is for each wind direction. So once we've calculated all these wind directions, we return alongside all of those wind directions a mesh that you can visualize in the SimScale platform. Now, it is also good to note that these meshes are created using a lot of automation and a lot of best practices. So we actually set up some fantastic automatic meshes for you, but you do have the option in SimScale to actually modify those settings as well if you need to.
Fantastic. Another couple of quick questions. Can you describe a bit more about the PwC metrics that you used there? What was it? Is it a Lawson plot? And what other kind of outputs can you get using the BM method you've shown here, please? Thanks.
Yeah, sure. So you actually get quite a lot out of a standard PwC solve. So we were showing the Lawson comfort criteria. That was actually the closest one to, say, the City of London guidelines, for example. We do also have many other variations of the Lawson criteria alongside NEN 8100 and also Davenport as well. So quite a lot available on the SimScale platform. Additionally to that, we have got those comfort criteria based upon not only the mean wind speed, but also the gust equivalent mean as well, which is quite useful. And in terms of other results, for each wind direction, you will get a full set of CFD results. So you will get your wind speed both in steady state and transient. You'll also get your turbulence quantities, and also you'll get your pressure values as well. So if you are actually less interested in pedestrian comfort and more interested in facade pressure, then you could also get that out of the same simulation.
Great, thank you, Darren. Let's take one last question. We have a user asking about surrounding buildings. So where might be a good source of data for surrounding buildings and the building context?
Yeah, there's actually quite a few different sources. So there's one particular source that is based on OpenStreetMaps. Now that's good if you are maybe at the early stage. You're not particularly fussed about the accuracy. You're just after a good representation. And that would be something like CAD Mapper. They do a fantastic job there. If you're perhaps interested in more detail and more accuracy, then services like ViewCity and also AccuCities we partner with quite a lot. And we've got quite a few demos on our website as well with AccuCities to show you how we've used their data to actually perform one of these simulations. So that's highly recommended.
Thank you so much, Darren. I think we'll leave it there now. Thank you everyone for your questions. If you want to get started with simulation in SimScale, please feel free to get in touch with us at sales@simscale.com. If you have a particular project in mind, a Revit model perhaps, or any other type of CAD model that you want to make simulation ready, again, please you can feel free to get in touch with us. And as also mentioned, we'll be sharing a recording and some follow-up resources to this event and this webinar early next week. Darren, any final thoughts for Revit users out there looking to make their model simulation ready and trying to get started with SimScale?
Yes, definitely for external building aerodynamics, it seems to be a really great fit. I saw a few of you asking if you wanted, asking to get hold of the scripts that I used in Dynamo. Of course, reach out to me. At the moment, I'll make it available upon request. Eventually, I might publish those online. But also, if you've got any ideas on how to make it even simpler for you as a Revit user, then also just feel free to share your ideas with me. I'd be really interested to hear from you.
Fantastic. Thanks everyone for joining, and wish you best in your projects, and we look forward to hearing from you. Thank you and good night.
Thanks very much, everyone. Bye.